Alright, hello class. Welcome to week 4 of SolidWorks. Um, just like the last few weeks, I'm going to go into and do a couple of these parts to show off some of the skills that we'll be learning this week. So the parts that I'll be going over is, first one will be part 2, to show off how to do what is called a revolved boss base instead of an extruded boss base. I'll be going over we'll do part number 6 to show off how to do a chamfer. So as a brief intro for those skills, let me make a quick sketch. So we'll do the line tool. So the revolved boss base tool is another way to create a 3D model out of a 2D sketch. And what it does is, given a closed shape, like with the extrusions, if I do revolve boss base, what I can do is I can take that sketch and rotate it around an axis to create a circular shape. So for me, for this one, this first box is the axis of revolution, and so right now it's spinning around the bottom line to create this wheel shape. I can also select it to rotate around the vertical line to create this more like barbell type shape. That's really all we'll really need for this class. We don't really need any of these other tools. Just making sure to have the correct contour selected, and if I hit OK, it turns that flat sketch into a revolved sketch. So you can use this to create circular patterns, much like this top dome over here, or like you would do in sketch 6. I would probably make this whole center base revolved sketch and cut out of it. Okay, so then next we'll talk about how to do a chamfer. A chamfer is done on any edge similar to fillets. It's just another finishing decoration, except instead of having a curve, it'll have a flat angled line. So the important things to note here are the size of the chamfer is done with this first box for distance, and then the angle of the chamfer is done with the second box. So in this sketch here on sketch 6, it's asking for a chamfer that is 0.03 in distance at a 45-degree angle. So if I hit 0.03, shrinks the chamfer relatively small, probably in millimeters. So let me get out of that actually. Let's change the inches real quick. Okay, let's reorient this guy. Let's look at the front view, hit space, look at it from the corner. We'll hit chamfer, and I can select any edge at 0.303 inches to create this angled edge. Like fillets, I would do chamfers at the end so that it doesn't mess with any parts of your sketch, and like fillets as well, unless it's an important part for dimensioning another feature, I would do them in 3D instead of in 2D. Just because doing it in 3D lets you rearrange it over here in the feature manager tree. If I had like other, let's see, so if I do a fillet on an edge, sure. So now I can rearrange them over here, and sometimes that's useful. Whereas if it's in a sketch, it's tied to the sketch and it's harder to undo. So if the fillet causes a problem, I can also use the timeline bar to roll back and edit the part in an earlier state. The third example will be for copying and pasting a feature in a circular pattern. So what we'll do is we'll just make a quick sketch on the top just to show it off. So we'll put a circle over here, and then let's go and extrude that 2 inches. That's too long, 1 inch. Okay, so if I wanted to copy this cylinder around the circle, I could do that. I could have done it in the sketch, but I could also do it over here in 3D with a circular pattern. So clicking on this tool, the first one is asking for the where it's rotated around. So you can pick any circle. So I can pick this edge, and you can see it's already starting to copy paste. I can pick the circle itself, does the same thing. If I pick this bottom circle, it's all it needs is some kind of round edge face in order to know what axis to copy and paste this around. So it'll share the same center point as whatever you select, and it'll maintain the plane as well. So copying and pasting the cylinder, which is selected by this boss extrude, I can change the number of instances, like so, and then I can copy and paste a couple times. You can copy paste any feature. Let's get into making these parts. Okay. So again, this first sketch, part 2, will show off how to do a revolved ball space. And so when I'm sketching this, it looks like the inside this line without the hatches, or sorry, these spaces without the hatches are open space, whereas the parts of the drawing with the hatch marks are solid material. This is view on the front view is a section view. So if you see these arrows up here, what's happening is this arrow is cutting the top view in half and then looking at it from the front. So we're peeking inside the object, which is what makes these different textures. And so when I'm drawing this, let's see, I definitely want to draw the inside hole, and then I probably want to see how to draw, probably drawing just this inside, anything that's revolved circularly. So I wouldn't draw the whole sketch because these outside bits are not revolved entirely around the same axis, whereas this cone-like shape is. So let's make a sketch on the front plane. So it looks like the whole thing goes to the side, goes up at an angle, goes over, making this trapezoid shape. I'm starting the midpoint at the origin just to lock it in so I don't have to add a coincident at the start. And so you can already see that it has some black lines because it's locked to the origin. Okay. Since it's being revolved 360, I only actually need to draw 1/2 of this trapezoid, and so I'm going to cut it off down the middle and just draw this right side. So I'll add a line here from the origin straight up, and then I will trim everything else. Okay. Now for this inside right half, it's a rectangle, a trapezoid, and then a squarish rectangle. So coming from the inside up here, taking my line tool And I'm just drawing that inside space to dimension in a minute. Okay. Since this is an inside space, I actually don't need this line, so let's delete that as well. And since this line up here and this line down there also aren't needed, so I can cut those out. So then let's make them separate lines to lock it back in, but they'll be construction lines. So center line down there and up there. Okay, so we're ending up just drawing this shaded region over here. And so let's add some dimensions. So from the center to this line is 0.88. Oh, I'm in millimeters, so let's undo that. Let's change the inches to match the inches at the bottom of the sketch. Do edit sketch. Okay, oops. All right, dimension this line there to there as 0.88. I should have started with the larger line, that's okay. This 3.25 goes from here to there. But do I have the thickness of this base? I think so. So we'll try it. Okay, so if I click on this point and the center line, that lets me go over to the left as well. So and go from like dimensioning this halfway point to dimensioning as if it were reflected. So that's 3.25. It's messed up my sketch a little bit. So let me fix that by just dragging this top point. This inner box has radius 50, so radius is halfway, and so if that's from there to there, 0.5. Okay, from this bottom box is 0.75 radius. Drag that down so it's a little bit clearer. So it looks like because of this 3.25, those go from the corner at the top of the base to the other corner at the top of the base. So when I am dimensioning, I'm sure it'll be fine. So I have to be careful when I'm dimensioning these two over here for this triangle, because I only have the sketch going to this top of the base. So the base itself has a depth of 0.5, and so with that in mind, the distance from here, the top corner, to the top of the base is going to be 1 minus 0.5, because I'm taking this dimension for the top and subtracting the width of the base. Let's fix that a little bit by doing that. And then from here down to the bottom is 0.75 minus 0.5 to make 0.25. Okay. And then we need something for the top of this hole, or we can just do from bottom to top. So from bottom to top of this cone-like part is 1.5. So we can do that here to there, 1.5. We'll fix the sketch by dragging. then the depth of the top hole is 0.38. Okay. So, and then the last bit is we need the circumference of this top rim, and that is, according to this, 0.25. Or 2.5, excuse me. All right, so we ended up from trying to sketch the entire front plane to just sketching this right half to then just sketching this shaded region up to the base. And so with a better game plan, we would have just started with this to begin with, but this is still fine figuring out as we go. So I want to take this shaded part and revolve it. So I'm going to go to features. Let's exit so that we can show what happens. So I'm hitting exit sketch. I'm hitting revolve boss base. It's asking me to choose an existing sketch. I can either pick the sketch from this drop down up here, or I can click on any of the lines in my sketch. Oops. And then I need to make sure to pick the right axis of revolution, which will be the center line. And then make sure my selected contours picks the right region. The preview looks pretty good. So I hit OK, and I've made that cone. Let me hit space to get to the front view. And up here at the top, you can do a section view to cut away part of the material. And so we can kind of compare this to the inside of our section view showing up here on the front view. So if I hit OK, it pretends to cut in half, but if I toggle it off, it's not. So, but it's with the section view that looks pretty close to, if not exact, to this top bit of the front view. And so now I can move on to making the base. So let's turn this off. Let's look at it from the bottom. So on this bottom, we're going to make this shape up here, keeping this hole because the hole goes all the way down to the bottom. So let's make a sketch. What I see here are two arcs on the side that connect smoothly with a straight line to the main circle. So I'm going to make two big circles on the end, connect them with lines to the main circle. Just haphazardly. Okay, let's start adding some relations. So let's make these equal in size. I want to make this and this tangent. It already looks like it is. Let's make these tangents. We'll make this line tangent with this circle, so that's smooth. Same on this side. Same here. Da-da-da. I could have saved time by mirroring, just doing one side and mirroring that over. But I didn't have that foresight, so I'm not doing that. Alright, so this outside arc has a radius of 0.75. So if I do that, do 0.75 times 2, because the symbol is asking for diameter. That symbol. It's made it crooked a little bit, so let's add a center line through the middle. And I want the point to be coincident on the center line. Okay. It looks like it's symmetric, so let's add a line down the middle and add some symmetry between these two circles. Okay, then we could probably put those holes in. So let's trim out the bits of the outside edge that we don't need. We need to redraw this circle because we don't want it to be extruded. So clicking on the origin to the circle, or the safer way is to do convert entities. Click on this circle. I might as well convert this outside edge because I need to connect these lines to those lines. So we convert both of those, and then let's trim away these two parts of the circle that we don't need to close it. Okay, almost there. We need the center to center distance is 4.5. And then we just need these two 0.63 size holes. These two will be equal in size, and they'll be 0.63 diameter. And that makes the space shape for us to then extrude. So I'll go to features, I'll hit extruded boss base, I'll look, see the preview, the thickness of the base as we said earlier is 0.5. Look at the preview again, that looks pretty solid, and so I hit OK. And then I hit Control 7 to make it isometric, and that looks pretty close to our part. And so the last step is I need to choose the material. I right click on material, click 1060 alloy. Then I go to evaluate tab, I hit mass properties, pull up the mass properties, and I'm ready to take my screenshot. So that's showing Revolved boss base. Again, we're going from a flat 2D sketch, choosing our axis, choosing the material to revolve, and then doing the revolution to make 2D objects into 3D in a circular way versus in a straight on flat way. Okay. I think for now I can do the circular pattern with just part 6. So we'll just do part 6 to show the chamfer and the circular pattern, and then we'll call it for right now. So let's make a new part. So let's see, we have two chamfers in this, one for the bottom corners of the inside corners of the cylinder, and then one on these outside holes. So when I'm drawing this, it looks like we have two circular revolutions, one for the main cylinder and one for the outside ring. So when I draw the shape, I'll cut it in half and ignore the chamfers because they're decoration. So I'll just draw a rectangle, and then so I'll go fully down over to the side and out, making kind of like a sideways T shape. All right, again, let's start with a center line. flip to inches, go back in the sketch. Okay. So some distance from the center line, we have this T shape, ignoring this hole because the hole will be added later. So going from out here, we go down, over to the side, towards the middle, we make the little T bump out, and then close it. It looks like I didn't make this a vertical line, so we'll add a vertical relation. We'll add a center line through the middle. We'll make these symmetric. We'll make these collinear. Same thing we've always done. Okay. Then we'll add some dimensions. So from this outside edge to the center, and sorry, not the outside edge to the center. Let's delete that. The diameter of this outside ring is going to be 1.5. This tells us that the diameter of the outside of the cylinder is 1. The inside diameter is 0.75. Okay. The height from the center to the top is 0.75. The height of the ring from top to bottom is 0.38. Okay, and that gives us a fully defined sketch to rotate, revolve. So I hit revolved, I select the center line as my axis, and it looks pretty good to go. So I hit OK. So then the next thing I need to do is add the holes. So because I drew it on the front plane and centered it on the origin, when I split this in half, right, I would just want to draw one of these holes, and I need a flat surface to draw on. So let's see. So splitting this in half for visual effect, because the original sketch was centered on the origin right in the middle of the part, that lets me use the right plane, which also divides it, let's see, as a reference point. I guess they're all reference points. Maybe in this case, let's do it like this. So the main issue I'm working with here is that I need a flat surface to draw on to draw these holes. There's a couple different ways to do this, but for us, I will show how to make a reference plane. And so I need to make sure I'm out of the sketch in the 3D space. Honestly, I'll just draw it on the front. So I need to draw something here, but if I try and put a sketch on there, it's not a flat face, so I can't select it. And so what I can do instead is add a reference plane. So I go to Reference Geometry, Plane, and it's asking for like enough information in order to put a flat surface on. So if I just pick the circle, it has some info, so it knows that it's supposed to be tangent, so it only intersects this, the flat surface only intersects the round surface in one spot, so to speak, technically a line. But it needs to define the orientation, and so if I go down to my drop downs, what I have to work with for flat surfaces are my planes. So if I can make it perpendicular. If I select the front plane perpendicular to the front plane, my reference plane highlighted in blue, or I can make it parallel, and it maintains that tangent relation from the first reference. Similarly, I can pick the right plane. Oops. I gotta delete this. I can pick pick the right plane to either put the hole on the front by making it perpendicular, or the right by making it parallel. I think it's most intuitive to say if I'm drawing the hole on the front that I want my reference plane to be parallel to the front plane and tangent on the edge. So that's what I'll pick for right now. Hit OK, and now I have my flat surface to draw on. If I go then and put a sketch here on the front plane, on plane 1, it's already selected, so it's already gone into the sketch. I will plop down a circle. And that circle has diameter 0.25. Okay, and then I can go and do an extruded cut. And this time, because of what I'm going to do in a minute, I can either do blind, that will work, and just cut it partially through. Or I can do up to next, and it'll start at the surface of the object and end when it hits open air. Cut out that hole. Looking at this, there's a chamfer only on one end because there's no chamfer indication on the other side of the hole. So I'm going to hit chamfer, under fillet, 3D chamfer to be sure. I'm going to click the edge that I want to make that diagonal edge on, put in the right size, so it's 0.03 inches, then hit OK. I can right click on the plane and hit the eyeball button to hide it. So we're almost done here. We just need to copy and paste this hole 4 times around the ring. And so I will do that with under linear pattern, there's circular pattern. I'll start with the direction, and again I can pick any circular edge with the same center point for what I want to copy paste this around. Edge or face. There's 4 holes, and then features and faces, I want to click on the cut that I did as well as the chamfer that I did. And just like in 2D, there's instances to skip. I can click on the pink dots to toggle them. I can increase the number of copy pastes with the number tool. But this is pretty good, so I'm going to hit OK. And it's copied the hole 4 times around, like I wanted. And so the last bit is I need the inside chamfers here. So I go to chamfer. This time the chamfer is 0.05 distance, and it picks on this edge and that edge. So I'm just clicking with the items the chamfer highlighted. I make sure it's 45 degrees, 4.05, that looks good. I hit OK, and my part is done. So if I assign a 1060 alloy, so that has the right density and mass, hit evaluate, I hit mass properties, I pull it side by side, and I take my screenshot. Alright, that's all for today. Thank you for tuning in.